Hi there. In this video, I want to talk about tolerancing your files. Now, tolerancing is probably the most important part of a project. It can be the difference between a piece that goes together really easily or a piece that's going to keep you up at night. So I've got two projects here, both of which can be found on our CNC Hub for free download. There's a little monitor stand here, which I'll talk through first, a nice simple one. And then we've got a slightly more complex, but equally just finger jointed kind of plant holder bench. I think there's a storage box as well that goes in here. So to start with, we'll look at this monitor stand. Now, simply both pieces are cut from 18mm birch ply, and it's just something to raise your monitor up off your desk. Now, very simple, we just got a pocket here for our legs to go into. Now, if we're designing this for 18mm material, and the material is bang on 18, and our slot here is 18mm as well, your piece won't actually go in. You need a larger pocket than the thickness of the material. So, as standard, what we say is to do about 0.4 overall as a tolerance. So where this is 18mm wide, we're actually going to make it 18.4. Now you can see I've actually already done this here. If I put in my dimension, you can see here that that's at 18.4. Although my model is actually 18, I've extended the pocket. Now what I've done is obviously all CAD software is different, but if I create my region here, I can just pull out one side 0.2mm and then move the other side another minus 0.2mm, and that would create our tolerance. Very quick and simple to do, but really makes a difference. The other thing is with finger joints. Now here we've created a finger joint system for the box. This is to increase surface area on our joints, meaning it's a bit stronger than the normal pocket detail. But again, we need to tolerance. Now, here we're tolerancing as well as our thickness of material, which is this bit, we're also actually tolerancing the width of our finger joints. If we leave them as is, once this finger joint comes in to the other, it's not going to fit because it's the same size. So again, we need to tolerance. Now, there's a couple of ways we can do this. We can either tolerance like I have here, by moving our fingers in 0.2 and 0.2. Now that gives us an overall of this finger, that's overall 0.4mm smaller than the corresponding slot. Now I wouldn't tolerance this slot because otherwise I'm doubling my tolerance, and that would end up being 0.8mm overall, and you'd have a very loose finger. So it's important when you're doing a finger jointed kind of box, it's important to only tolerance one side. The other way we could do it is we could just tolerance everything by 0.2mm. Now, one way of doing this is just offsetting our entire shape by 0.1mm. Yeah. Now, although that does change our outlines on the rest of the piece, only fractionally. So on something like this, you wouldn't notice. But what it does do is it creates our tolerance on our finger joints here. And it just means that everything was slot together. Alternatively, what we most commonly do ourselves at this end, because we don't like altering the overall shape of our pieces, is just moving individual parts. So we've moved that up 0.2 and then that down 0.2, and then that finger joint would then be toleranced. As I said before, it's just important to keep track of what it is you're tolerancing, because you don't want to double up and tolerance both sides, because otherwise it would just be far too loose. The other thing is it's also important to tolerance your inlines. This is just a handle, so that doesn't matter. But anywhere where you're going to have pieces of material slotting into other pieces of material, it's really important to tolerance those slots. So for this one, it's important to get the thickness right as well as the width of the hole. Now, one important thing to mention with tolerancing and using sheet material is that although sheets are advertised as, let's say in this example, 18mm thick, they are given a tolerance of their thickness by 0.6 mil either side, meaning you could have a sheet that's 18.5 mil thick, or you could have a sheet that's 17.4 mil thick. Now, on the majority, depending on which supplier and which brand we buy from, the majority of our sheets will be closer to 18. So it's a good basis to obviously go off. But if you do have a specific job that you're doing, it may be worth calling us beforehand, seeing what stock we've got, what we're kind of general kind of measurements we're getting in thickness, and design to that. Because if we've got material in that's measuring at 17.5 mil thick, then there would be no need to tolerance any of these slots for your thickness anyway. You would need to tolerance your width of joints. I hope that helps, but yeah, basically take away 0.4 mil is a really good basis for what kind of tolerance you want to give your parts. Hopefully that's helpful, and let us know, get in touch if you want to know anything else. Thanks.